Hello, and welcome to CEM and Lucidity Systems Wednesday webinars on separation solutions. Today's presentation, Recent Developments and Innovations in Gas Chromatographic Hardware, is presented by Dr. Ronda Gras of the Dow Chemical Company and Dr. Alicia Stell of CEM and Lucidity Systems. As a note, this presentation was previously recorded and is presented with permission from Dow Chemicals and CNE News. Before we get started, let's review some of the features of GoToWebinar. The audio for this presentation is available on your computer only. If you cannot hear the audio, please check your speaker volume. To access the handouts for this presentation, click the handouts icon and then click the handout you want to access. The handout file will automatically start downloading from your default web browser. At the end of the presentation, we will have a question and answer session. You are welcome to submit questions at any time during the presentation. To do this, please type it in the questions section and click Send to submit the questions. Please note that not all questions may be answered live, but they will be answered by email after the webinar concludes. It is now my pleasure to introduce today's speakers. Dr. Ronda Gras is a research scientist of analytical science, core R&D of the Dow Chemical Company. She has held many critical positions in manufacturing and R&D environments at Dow. As an analytical scientist, Ronda is most passionate about separation science, particularly gas chromatography. Her area of research includes high-resolution chromatography, hyphenated techniques, and ultratrace analysis. Ronda has authored or co-authored more than 60 scientific publications in peer-reviewed journals. She holds 3 patents and is the recipient of 4 external awards. Dr. Alicia Stell has worked with CEM for the past 14 years, joining after completing her PhD in analytical chemistry. Her extensive background in chromatographic analysis and her mechanical expertise have been instrumental in the development of novel systems for sample preparation and analysis. With that, we are ready to begin our presentation. Ronda, over to you.
Thank you for the kind introduction. It's a pleasure to be here. Thank you to all the participants for making the time to talk about some of the latest developments in gas chromatographic hardware. Now, it might seem rather counterintuitive to talk about the latest developments knowing the maturity of the technique. But we've had an opportunity to work with the Mini GC, and we thought we'd share some of our experiences with you. I'm presenting this work and our perspectives on behalf of my co-authors listed here on the slide. As an outline to the presentation, let us look at the impact of gas chromatography in society and its role at Dow. Then, if we're to embark on the journey of building a miniaturized gas chromatograph, let's discuss some of the desired attributes. Then, we will explore the current features, innovations, figures of merit, advantages, and constraints of the current configuration, and of course end with conclusions and acknowledgements. Separation science, specifically gas chromatography, is a near ideal technique. Without much effort, it is a technique that can be practiced by the novice to the expert, where excellent results can be achieved. The technology can separate complex mixtures. It can detect a wide range of analytes from 2 to 1,000 daltons, and it can quantify results for data-driven decisions. The technique is both relevant and prevalent in a number of applications and industries, ranging from food, forensics, and transportation, to name a few. And it's because of these features, we believe which is most interesting is the technique, despite its age, has not diminished, but yet increased and enhanced in its importance because it's able to collect data to solve some of the world's most challenging problems. The role of gas chromatography at Dow is quite significant. Analytical science of core R&D was an early adopter of the technique. Today, several decades later, thousands of gas chromatographs, whether they be benchtop, at-line, or portable, analyze volatile and semi-volatile analytes to support our operations, such as process optimization all the way to our site license to operate. Gas chromatography also plays a significant role with hyphenated techniques, such as headspace analysis for pre-concentration or with mass spectrometry for analyte identification. The strengths of gas chromatography are plentiful, some of those listed here on this slide. And amongst our community of practice, we have a saying that the technique separates molecules but unites people because it helps us to collect defensible data to support our current objectives and our future goals. GC as a technology is quite advantaged as there's a variety of form factors available to us. On one end of the spectrum is the research-grade benchtop gas chromatograph. This is the workhorse of the technology and where I spend a majority of my time. They are high performance and well developed. They're flexible and scalable, but they require a higher skill set and higher cost to operate. And because of their size, there is a lack of mobility. They can become a dedicated analyzer, and in this case, can be over-prescribed. On the other end of the spectrum is the micro gas chromatograph. And because of their small size, there is some mobility opportunities, but typically they're limited in capabilities. Further up the spectrum are portables and sensor technologies. These simple-to-use handheld devices can conduct measurements right in the field in real time, which is a huge advantage. But these handheld devices are typically for targeted use and can be susceptible to false positives and false negatives. So a need exists that combines the performance of a benchtop GC, but captures the simplicity of a micro or portable gas chromatograph. In this space, a mini GC should provide some reasonable performance and capabilities, while at the same time be simple to use with plug-and-play technologies like the connection and control to software. Automation is also a huge benefit. Shown here is a pictorial description of current commercial GC platforms available. If we use transportation as an analogy to the different platforms, we might describe a sensor like riding a bike. A bike is great to get us to the corner store, keeps us active, but we might only drive it in sunny weather. Other times, a jet is required to help us reach our overseas long-distance destinations. But in many cases, a robust and reliable car, like a mini GC, will simply suit our needs. From our perspective, some of the desired attributes for a mini GC would most importantly be to retain critical capabilities. Critical capabilities like temperature programming, so we can adequately and properly separate a wide range of analytes. The system must also have a robust measurement process, be sensitive, repeatable with good separation power. And lastly, it must be suitable for dissimilar matrices. Green and circularity considerations like low power consumption, reduced noise pollution, and the use of a standard power receptacle are desired features. A small footprint not only reduces the burden on expensive space capital, but also opens opportunities for field, online, and at-line deployment. And lastly, a simple-to-use and configured platform is amenable for educational institutions where the learning and the application of the technology is so critical. As an industrial and R&D organization, Dow is interested in advancing gas chromatography in all form factors. Modularization and miniaturization is an important aim as it widens the envelope of applicability and advances portability. Our collaboration began with CEM about a year ago, and we'd like to thank them for the partnership. The photograph shown on the left is the Mini GC in its transportation packaging, and on the right is a photograph of two Mini GCs with the laptop control software. Column installation poses a challenge in the current practice of modern gas chromatography. The lack of a consistent column installation can lead to split discrimination, peak tailing, and reduced sensitivity. While it might seem simple and straightforward, it is so critical. Even on the same team, we each install the column a little differently. And with small deviations, there is a potential for the results to be altered. One of the first and most unique innovations of the Mini GC is the column housing module, which supports standard capillary columns. Although the column installation isn't eliminated, it is standardized. Here, commercially available capillary columns can be installed into the column housing on the bench with good ergonomics and at room temperature. The photo on the left shows the column installed in the column housing. The second innovation is the ease of column installation into the GC system. The center photo exposes the heating sleeve or heating jacket with the column cassette resting on the top of the gas chromatograph. The column in the column holder can be simply placed in the column cassette via two guide pins. The column cassette is then guided into the heating sleeve and connects simultaneously to the inlet and the detector by solely turning the front knob about 1.5 rotations to complete that connection. The turning knob is shown in the photograph on the right, and the entire process takes only a few seconds. Besides selectivity, the second most important variable in gas chromatography is heat management. Heat management is important for temperature programming capabilities and for consistent retention times for analyte detection. Heating via a convection oven provides many advantages, such as consistent heating across the entire length of the capillary column and a low cost to operate. But the price one must pay chromatographically comes in the form of a longer cool-down time. Cool-down time can be reduced by the reduction of thermal mass, and this clever and compact design optimizes the heating and cooling with the reduction in oven size. The photo on the left highlights the small oven jacket, which is a mere 4.5 by 5.5 by 3 inches high. This is about a 17 times reduction compared to a standard GC oven. And as an oven jacket compared to an oven bath, let us re-examine the hand and glove design where the column cassette interconnects with the inlet and the detector both seamlessly and simultaneously. In the photo on the right, it highlights the compact cool air intake and cooling fan which enters the oven on the side. Another very important variable for a chromatographic system is accurate flow control. Modernized digital pneumatic control offers several advantages. First, the capability for rapid changes. Second, reproducibility. And thirdly, accuracy. And accuracy is everything. In fact, without accurate pneumatic control, we essentially cannot practice modern chromatography. The Mini GC incorporates digital pneumatic control, which is shown on the photograph on the right. The photo on the left highlights the main gas connections, the carrier and detector gases, which is located on the backside of the GC. An inert sample flow path is critical, and nowhere is it more critical than in the inlet. For example, if we lose 50% of a reactive analyte in the inlet, we will lose at least 50% detectability by the time the analyte reaches the detector. As shown on the photograph of the left, the inlet on the Mini GC is passivated for improved inertness. The photograph in the right shows the pneumatic control system, the split-splitless inlet, and the oven module. Besides passivation, what we find very exciting is the novel design of the Mini GC's split-splitless inlet. In the split-splitless inlet, we use the same inlet liners and fundamentally the same basic operation to other modern split-splitless inlets. But what is interesting is the connection to the column. The sample flow path takes a 90-degree turn, which is completely not traditional. Also, the liner sits in the rear spacer nut, which holds the unique column transfer lines. This is a screen capture of the analytical software while in results mode. The software is quite interesting and informative. At one glance, you can see your chromatogram along with live conditions. The upper ribbon of the screen is a convenient dashboard of current critical conditions. It shows we have an auto sampler, what column we're using, and our temperatures and flows. Below the ribbon is our chromatogram on the left, the analytical results on the upper right, and on the lower right-hand inset is our interactive integration. The chromatogram shown on the screen is a hydrocarbon mixtures ranging from C8 to C16 along with aromatics. This covers a range of volatile and semi-volatile analytes typically found in common applications such as natural gas, taste and odor, inerts, and gasoline, to name a few. The chromatogram not only illustrates the good separation and good peak shape we've become accustomed to with contemporary capillary chromatography, but is also a result of the collective innovations of this mini gas chromatograph. The yellow dot on the apex of toluene highlights the peak we're currently integrating. In the inset, we can integrate the peak in real time with the updated results shown above. In chromatography, one of the enemies of the technique are cold spots. Cold spots can cause a lot of challenges, and worse yet can preclude applications with heavier molecular weight analytes such as additives or simulated distillations from being conducted. Cold spots can broaden peaks and can trap analytes that can be detected in the next and even subsequent injections. To test the Mini GC for potential impact of cold spots, we extended the hydrocarbon range to NC36. NC24 with a boiling point of 390 degrees Celsius can sometimes mask any effects. But NC36 with a boiling point of almost 500 degrees Celsius is a true litmus test for effective thermal management. And what we see is excellent. The peak symmetry is very impressive for this newly conceptualized miniaturized gas chromatograph, despite the addition of a new inlet design and two unique interfaces that connect the inlet to the column and the column to the detector at right angles. Now, a careful eye may detect a slight broadening of the alkane series with time, and this is true because we're starting to operate in the high temperature isotherm. If we carefully examine NC36, we can see that it is a bit broader, but the peak width at base is a mere 0.1 minutes or 6 seconds, which is really excellent. And look at the peak symmetry. It is gorgeous. Chlorinated phenols like pentachlorophenol have been used effectively as an insecticide, herbicide, fungicide, and as a wood preservative. However, Chlorinated phenols are toxic to a wide variety of organisms and are widely distributed in the environment due to their hydrophilic nature. As such, the analysis and monitoring of trace-level chlorinated phenols is relevant. And to conduct this analysis requires a highly inert analytical system. In fact, without an inert sample flow path, the applicability of the system would be quite limited for this and many other applications. In this chromatogram, we're demonstrating the system inertness using 5 chlorinated phenols, and the results are quite respectable. Moving forward to the figures of merit, let us examine the system repeatability. Repeatability is critical as it provides us the confidence in our results. It is the culmination of all aspects of the sample measurement process. And here we were able to achieve less than 6% relative standard deviation on area counts and less than 0.04% relative standard deviation on retention time for the alkanes shown. Taking a closer and broader look at the retention time repeatability, the repeatability is about 0.1% for analytes with a retention factor of less than 5 and 0.04% or less for analytes with a retention factor greater than 5. The analytes with less retention do not have the advantage of thermal focusing and are more impacted by the pneumatic control system. But the difference between the two groups is a variability in the second and third decimal point, which translates into less than a second. So despite being 10 times higher, the results are quite acceptable. The split-splitless inlet is a critical sample introduction approach for fast gas chromatography. Some of the compelling reasons for this notion are, it is a practical approach for capillary columns where analyte loading is quite limited compared to packed columns. It has a faster transfer of analytes suitable for faster GC, and it can easily be operated by analysts with different levels of experience. Also, the split-splitless inlet can operate with both gases and liquids directly. In the graph, we are plotting the split ratio of 10:1 to 100:1 versus area counts of the hydrocarbons listed. The good linearity over this range provides evidence of good splitting and effective mass transfer. We hope through this presentation we have highlighted the many advantages of the miniaturized GC. This simple yet capable platform includes plug-and-play software technology, the incorporation of automation through an automated injector, and has a new and novel column form factor, which has effective intercolumn connectivity, can conduct rapid column changeout, and has effective thermal management. On the other hand, we must understand the envelope of operation. Some advanced integration options are not included in this simplified format. The autosampler requires very careful alignment of the syringe to the injector nut. And we have also noticed some heat transfer from the GC column to the GC chassis, which could be improved through additional insulation. And lastly, the GC utilizes one inlet, one column, and one detector, which might preclude its use in some techniques like Dean switch, which requires 2 detectors. But really, this is the advantage of the system as we seek for a robust and simplified platform. So in conclusion, despite its maturity, GC technology continues to evolve, innovate, and develop to serve the analytical community of practice. The development of this highly capable miniaturized GC has addressed a gap in the GC instrumentation spectrum, represents a new strategy in practicing GC, and has widened the field of applicability. The feature set of this miniaturized GC are relevant, as innovations achieved today will define the development of the technology in the future. And lastly, the Mini GC is a technology of the future, here today. Lastly, I'd like to thank those listed on the slide for their support and guidance during this project. I'd like to thank the audience for their time and attention, and I would now like to pass the presentation to Dr. Alicia Stell of CEM.
Thank you, Rhonda, for that presentation. It was really validating to see what you've been able to do with the Mini GC. So before I get into the bulk of my talk, let me give you a little bit of background on where the Mini GC originated from. So the Mini GC was designed and developed by Lucidity, a division of CEM. I personally work for CEM division, and I have for the past 14 years. And now that these Lucidity products are coming online, CEM itself will be supporting these products from a sales, service, and application perspective. So my team at CEM, the molecular team, will be supporting these products. So with that, let's talk a little bit more about the Mini GC. So a lot of what I'm going to be talking about here today, Rhonda certainly touched upon in her presentation. But I think most of you guys know it is a very common thing that the more we repeat something, the more we remember it. So I really want to touch upon the most important aspects of the advantages of the Mini GC, even if it is a little bit repetitive from what Rhonda said, and just hear it from my perspective. And again, the more we talk about it, the more you might remember it down the road as far as what the Mini GC brings to the table. So I'm going to cover the small footprint, the ease of use, the affordability, and the results. So with that, let's talk a little bit more about the small footprint. So some of the obvious things that come along with the small footprint is the fact that it is lightweight and you can easily move it. You can easy installation because you can pick it up. I mean, I could pick it up myself, put it on the bench top and get it installed, no problem. And also if I wanted to move it to another side of the lab or a different lab, that's going to be very simple due to its low weight and small size. But there's some advantages beyond just that. With this small size, you also get a low power consumption. And in our world, where we are going to very green and looking at our footprint and what our power consumption is, it is really important that we start to have lower power consumption overall in our labs. And so the Mini GC is bringing that as an option to have something that doesn't require the power of other systems. Also, in this small package, because you have a small oven, it doesn't take as long to heat and cool. So you get an advantage from the method perspective as well, as far as faster heating and cooling times. So sometimes you got to look beyond just the small footprint because there's a lot that brings to the table. So now let's move on to the ease of use. Now, the ease of use is where I'm going to spend the bulk of my time, right? Because I really feel that that is the biggest part of what the Mini GC offers. And I'm going to focus on two main things: the cartridge column installation and the user-friendly software. And I've got videos of both of those to hopefully really bring a visual to how simple these things truly are. Now this video is very quick, I will warn you, because it is that quick to install a column. So I won't talk too much through this, I'll kind of explain it more after because it's done already. Okay, so for me to explain all the details would have taken longer than if I had actually done it. Okay, so it takes longer to talk about it than it does to actually do it. So as you saw in the video, the column is really easily installed. You simply remove our column caddy, you drop in your column, and then you put that column back in the system, column caddy back in the system. It's that simple. It literally takes seconds. So let's talk a little bit more about that, because you might be like, hey, that's great, love that, but do I have to use a specific column? And the answer to that is no. We are not limiting to your column. Now, you must have your column installed on a column holder. So it does have to be at a certain diameter, and you do have to install it on this specific holder to install it in the Mini GC. Currently, right now, there are some options that you have. You could purchase the column on the column holder already. That's obviously the simplest option. And as pictured, you can purchase that directly from ResTech. Now, if you wanted to use some other column, you can easily install that yourself. You just got to make sure that it is wound at 4 inches or less, and that you install it properly onto the column. But it is no harder to install that column onto the column holder than it is to install a column on a standard GC system. So hopefully that shows you how real simple the column situation is. I mean, it really is like just putting in a video game. It's that simple. And I think that's one of the bigger aspects of what the Mini GC offers to this industry. So let's talk now about software. So in this video, you'll see me quickly navigating through the software. And what you see from the front plate is you get a visual of everything going on. So you always know the temperature and connections and so forth. It's more pictorial. It's not menu-based. Now I've opened up the results. You see the results here. You can highlight a peak and get the details of that peak as far as the integration is concerned. It's just really user-friendly. You don't need a tutorial here, right? Most GC software is a lot of work and it's not intuitive. This one I can probably put in front of anybody and you're going to figure out how to use it. It's that simple. And it's just that. You've got your methods, your results, and your run. That's it. Very simple, very easy to use, and really opens up for a non-trained technician to be using this software on a daily basis with no problem. So I really hope that I covered the fact that this system is truly easy to use, not just from the hardware perspective, but from the software perspective as well. So now let's move on to the affordability. Okay, because often we kind of think of lower cost items as maybe cheap, and cheap makes you think you lost some quality in that, and that is indeed not the case here. We really like to use the word cheap, not affordable, not cheap, because this is affordable. They are not as expensive. The Mini GC is not as expensive as a standard system would cost. So there's cost savings here, and you get all of these benefits that it brings to the table. And I think the biggest thing that you get out of this is it makes it accessible to more. Right? Because there's a lot of labs out there that may think, no, we can't do that. That's too complicated, or that's too expensive. There's things there, right, that they'll come up with and say, no, we're going to still outsource our data, or we're just not ready to make that move at this time. And we hope what we bring to the table is expanding the GC FID market, make it accessible to more, because anybody can run this. You don't have to be a trained chemist. It's really plug and play. And that offers up, more. And a lot of the times, as people, the affordability really comes into play there too. So the fact that you can get something that's easy and affordable is a big advantage. So let's move on and talk about results. So I'm not going to spend too much time on the results because I think Ronda did such a great job on that. And I don't want to take away from anything that Ronda presented. But one of the big take homes there was the range of hydrocarbons in which the Mini GC is able to get accurate data for. And it's a big deal to be able to run both gasoline and diesel samples on the same system with no compromise in data. And so that's all I'm showing here is you get a very standard gasoline profile and a very standard diesel profile. I've just overlaid these two runs so you can see that indeed we did this on the same Mini GC with similar methods. And so just, again, a very wide variety of applicable applications because you are not limited in the scope of what you're able to look at. Whatever you can look at with the standard GC FID, you can look at with the Mini GC as well. So to kind of conclude, I want to talk a little bit about flexibility of the system. I hope you've seen that it's flexible from a user perspective, as far as that ease of use with the column, and you get to choose your column. You're not limited to your column. But even furthermore, you're not limited to your application. Right? A lot of people tuning into this particular presentation may be in the petrochemical world. However, we're not limited to the petrochemical world. The academic, environmental, food, consumer products, and natural products are just to name a few. GC FID is very widely used within all of these industries, and the Mini GC applies to all of them as well. So again, any application that you would typically use a GCFID for, you can use the mini GCFID for. So it's very flexible. It's not designed for a specific application. It is a very well-versed instrument that can be applied to your standard applications in a lot of different areas. So with that, I hope you've seen that the mini GC is small, easy, and low cost. And I have not had time to talk about it in this because we're focusing on the mini GC, but another product from Lucidity is the mini gas. The mini gas is a hydrogen generator. So with the mini gas combined with the mini GC, all you need to run is DI water. And both systems install in 30 minutes, self-installation. So you get these boxes in, 30 minutes later, it's on the table, it's running. Lucidity provides everything you need to do to run. Like I said, all you guys need to do is have some DI water. So really think about how that opens up the spectrum of who can run a GCFID, right? Because again, these academic labs that, really, okay, it's going to be too complicated, or this lab that was outsourcing all their data can really think about having their own systems. And that really is awesome. This simplicity, this ease of use, this plug and play really opens up the genre of GCFID and makes it accessible to all. And so I hope that you've seen that in this presentation. So as noted, I work for CEM Corporation, and I have for 14 years. And I think one of the things I'm most proud about in working with CEM is the fact that we are where you are. We have tremendous support from a sales, service, and applications perspective. I can tell you this is true. We are here to assist you. And this is true not only on the domestic scale, but on the international scale as well. So from a global perspective, CEM is here to assist you. And again, I can attest to it from a personal experience. I am communicating on a global scale with our customers, with our potential customers, and ensuring that they get the product that suits their needs and that it's working for them. And so that's just one of the things that the fact that CEM is supporting these Lucidity products that we bring to the table for these products is you get the reputation of what CEM is behind these Lucidity products. And so I think that is just a really strong statement and really helps customers ensure that they're going to be supported properly. So here are the faces behind the work that I presented here. And as noted, my team, the molecular analysis team, is going to be the team supporting these products. My team consists of myself, our senior scientist, Candace Cashman, our product specialist, Brittany Fessler, and our application scientist, Benedict Liu. On the Lucidity side of things, you've got their president, Mike Collins, and their R&D scientist, Daniel Iverson. And I have to note that, a lot of people to picture here. There are more people at Lucidity, and a huge thank you to them as well. But Mike and Daniel are certainly the ones that I am interfacing most with regarding these products at this time. And so they're the ones that made this presentation possible. And also, a huge thank you to Dow, so the Analytical Science Group at Dow Canada, particularly Ronda Gras, who gave the presentation, and Jim Luong has been very instrumental in this as well. And a big congratulations to Jim. He just got the Power Award for Analytical Chemistry, 3rd year in a row. That is unheard of. So big congratulations to Jim. We are just so happy and grateful to have this opportunity to be working with him. So big thank you to Dow. Overall, this would not have been possible without them. So thank you.
Thank you, Rhonda and Alicia. That was a very informative presentation. We will now begin our question and answer session. As a reminder, to submit a question, please type it in the space provided and click Send to submit. For this question and answer session, we are joined by Dr. Jim Long of the Dow Chemical Company.
So our first question is, let's see, how often do you conduct inlet maintenance and is it difficult?
Thanks, Leanne. I can take that question here.
Thank you, Rhonda.
Yeah, so inlet maintenance, of course, holds true that it's a function of the number of injections you make, the amount that you inject, and of course your matrix. So those principles still hold true. Now, when it comes to the actual logistics of changing the liner and doing inlet maintenance, it's slightly different because of the unique inlet design, but it's not any more challenging. One needs to remove, of course, the septum nut, replace the septum, replace the liner, and if inlet needs to be cleaned, we need to look at removing the rear injector nut.
Excellent. Next question is, what is the possibility of integrating a gas sampling valve for gas analysis?
Yeah, that's very straightforward as well. Has not been done yet, but simple to do by adding it just upstream of the inlet injector as well. And here we want to add in a 6-port sampling valve. This is important when we want to conduct a gas analysis and to get better repeatability with the injection of any type of gas, whether it be a standard or a sample. And we can use any commercially available gas inlet valve. You need, of course, a solenoid and an actuator, which you time into a contact closure.
Excellent. Thank you for that information. Let's see. Our next question is, earlier you mentioned about the technology is amenable to academic purposes. Can you expand on this?
Yeah, and I think Alicia talked about this as well. It's a cost-effective and reliable system. And also it has all the features of any standard gas chromatograph. So from an academic perspective, at a lower cost, you can increase your student instrument ratio and have a lot more hands on deck and a lot more learning opportunities for the students. So we see a really nice fit there.
Excellent. All right, our next question is, can you use a column other than ResTech on the column holder?
Leanne, I'll take that question. So yes, the short answer is yes. Now, I will note that we have worked with ResTech to have part numbers such that you can actually buy an MXT column already on the holder. So that is an added advantage there. And ResTech currently is the only company that you can do that. However, you can do whatever company you would want, whether it's ResTech or Agilent or Phenomenix. Just make sure your inner diameter is 4 inches or less. That's the important factor there, is that the diameter at which the column is wound. We do have a smaller oven, and therefore it does need to be at that smaller diameter size. It is connected to the column holder with standard fittings and ferrules, so you would connect it how you would any column. So yes, you can use other columns outside of ResTech, but there may be an advantage of using ResTech to get it on column holder.
Excellent.
And I think Alicia's comment is correct. What I would add is that making sure that the most popular operation for a column will probably range from 180 micron to 320. I wouldn't recommend a 530 micron where the coiling distance will be a challenge to the column, or a 100 micron column where we might end up encountering the issue of extra column effect band broadening.
Yep, I agree with Jim there as well. And just to add a little bit more on their restraints, they wind columns at an inner diameter. They're not really looking at the outer diameter. So if you had a 60 meter or 100 meter column, it may get to the point, depending on the column, where that could get tight to fit in. So you may have to look at that column length as well and ensure that you are sticking within our outer diameter restraints from that point on. But the majority of standard columns should fit.
Excellent. Okay, good to know. Great discussion. Our next question is, how fast does the mini GC ramp to temperature?
I can start with that one, and Rhonda maybe has even more experience to kind of talk about actually running it. But in general, and I'm totally escaping my mind on the actual ramp time at the moment, but it's faster, right? So mention the fact that we have a smaller oven. Well, it's a smaller space, so you can heat a smaller space faster. So typically in a matter of minutes, you're going to be at your start temperature that you would want to ramp to. So you are going to see an advantage in time from run to run, right? So that it is going to cool faster and it is going to get to temperature faster than a standard oven. So overall, you're minimizing that time between injections.
Okay.
I can just add to that the temperature programming rates that we worked were in some place in the range either 10 degrees C per minute, 30, and even up to 50 degrees C per minute. And the main of which the oven in general can keep up to those temperature programming ranges, but what you're actually looking for is consistency run to run. So we may lag a little bit at the higher end temperature programming rates, but what you're looking for is consistency, and that's shown in terms of repeatability of retention time.
I will also add the comment that Rhonda just made is that temperature programming rate is something that an analyst need to pay attention to. You could over programming in such a fashion that destroy chromatography. So the rule of thumb that proposed by Blumberg and Klee is essentially 10 degrees C per void time. When you stick with that, you have excellent chromatography.
Excellent. And the next question we have is, can you do split injections?
So yeah, I can take that one. The answer to that is yes, you can do a split injection. You can also do a split less injection. So that will be your choice, but you can run any splits, up to 1 to 100, and that is going to run as it normally would on a standard GC/FID system.
Thank you, Alicia. At this time, we have a few more minutes if anyone has any remaining questions that they'd like to have answered. I'll wait for just a moment. Thank you so much to Rhonda and Jim from the Dow Chemical Company, and thank you to Alicia for joining us today for this presentation. It doesn't look like I have any other questions coming in, so we will conclude this webinar.
This concludes our presentation of recent developments and innovations in gas chromatographic hardware. If you have any further questions, please email organic.support@cem.com. Thank you for your attention and for attending, and we look forward to seeing you at 3 p.m. for Dr. Nick Snow's presentation, Making Gas Chromatography Greener, using common sense optimizations, simplified methods, and miniaturized instrumentation. Goodbye.